Now it is possible. Have you seen? How did you feel? Right? So good evening, students. So yesterday we have seen that crystallization. Am I right? Crystallization only we have seen. Today we have to complete this unit. So yesterday we have completed crystallization. What I said, for the solid, if you want to purify, you can purify via crystallization and then sublimation. So sublimation means the substance it has to volatile. So when it volatile, it will you can purify whatever we have camphor and naphthalene, no, that will volatile. So by using that method, we can purify. Crystallization, the yield will be less, but you can purify the solid substance. So you have to what you can follow, no. So you should have the substance should soluble in what solvent, partially soluble. The impurity should not be soluble. So after dissolve the compound in the solution, you have to heat for that, and then if you are cooling at room temperature, the crystal will grow off. Then if you are filtering, you will get the purest one. Okay. So the benzoic acid mixed with naphthalene, which was purified by the hot water. Okay. So the benzoic acid crystallized, and the separation mixture of naphthalene and phthalic anhydride by using hot water, we can do the simple crystallization. Fractional crystallization means, so different solubility of the different component in the solvent. What is solvent? What is solvent? What is solute? Solute. That's it. So if you have larger quantity, that is solvent. Lesser quantity, it will be a solute. So generally, when we take the sugar solution, sugar is the solute, water is the solvent. Okay. So you have solid solution also. Okay. This is solid liquid, whatever we are using, simply we are saying, but we have solid solution also. In that, whatever you are taking the alloy, alloy is a solid solution. So you have one more metals which is less in concentration, and the other metal will be in the large concentration. So that is known as solid solution, or otherwise stones. That is also solid solution. Okay. Now the compound having less solubility crystallize first, then the second one by using the fractional crystallization. So it involves the dissolution of mixture in small quantity of hot solvent. When the concentrated solution is allowed to cool, which is having less solubility, it will crystallize first, then the more solubility will crystallize later. Okay. So by your filtering of you will get some concentrated solution. From that, the second one will come. That is known as fractional crystallization. By this method and all, we can lose their yield. Yield means whatever you are taken, that is yield. So you are taking 10 gram of compound. After the crystallization, if you are getting 3 gram, 4 gram means you lost 6 gram. So you will get the loss, but the purity will be better purity. Okay. Now we'll go for the distillation. So if you have two liquids, different boiling point, that can be separated by the method. So what is the principle behind that? When this liquid will boil, when the pressure which are equal to atmospheric pressure, then the solution get boiled. Okay, that is boiling point. So once the boiling point reaches, the liquid, whatever compound you have taken, that will be boiled. So first, the liquid which is converted into gas. So during this process, what will happen when the liquid you are having? So that liquid you are heating. So the liquid when you are heating, it converted into gas. That will become hot. Okay. When you are cooling the gas, you can get the liquid A. So after some time, liquid B. So which is having boiling point less than the liquid B. So which is having lowest boiling point, that will come first. Then the temperature you have to maintain. It should not rise. For example, the two compound you are taken, one having 130 degree, another having 220 degree means. So 130 degree you have to maintain. Okay. So 130 degree, you will get the compound A. At the constant temperature, that liquid only will come. So that you can measure in the thermometer. So what is that real apparatus? You have to take the flask. You should have the thermometer. Okay, this is thermometer, and then you should have the condenser. So kindly bear with my diagram. So always the condenser, you have to give the cool water over here, cooling. So inlet. This is become outlet. So the compound you will have here, then you have to heat it. Then you can collect it. Collecting reservoir. So water inlet you are giving over here, and then once if you are heating, what will happen? The liquid gets gaseous state. Okay. So gas, if you are cooling, it will get the liquid. Simply, you are taken a vessel, you are having water, and then you are closing. So before closing, you are seeing the plate which is very dry. Then you are keep on heating. What will happen? The steam will come. So after some time, the steam will be deposited in the cover of the plate, bottom side of the plate. So you have the liquid drops. when you will get the liquid drops, you have to take an away, and if you are keeping aside, it will give the liquid drop. So it has to cool. So by this way, we can purify. That is known as distillation. So when the two liquids having difference in 10 to 20 degree Kelvin, it can be separated by using the distillation. When the two mixture liquid is heated, the low boiling point will come first over the other boiling point left behind in the flask itself. So this is known as distillation. So this distillation, again, you can have the so you have the fractional distillation. Sure. So for the fractional distillation method, so this can be, you can take if the two liquids having very near boiling point, for example 60 and 65 degree or 70 and 75 degree. If you want to purify by taking the distillation only for the liquid sample. Please remember, for the purification of liquid sample, we are doing the distillation. So for example, you can distill water also. If you want purest water, whatever contaminated water you are having, that you put the potassium permanganate, all that decomposed material will become deposited in the RB flask itself. The pure water will come out. Suppose if you are mixing that with along with some other liquid, means it is having 5 to 10 degree difference. That can be, you can separate by using the fractional column. So the fractional column, it will be inserted between your flask, RB flask, and then condenser. Okay, so you are increasing the height. That's it. Nothing you are doing, just you are increasing the height. So in that height, so you have the different shapes of fractionating column. Okay, so in this you can have the bulbs like this. That column will become like this. So you are keeping the distance very large. That's it. Okay, and then so you have to keep the thermometer over here. So this will be connect with your RB flask. So those things you have to connect with your RB flask. So here you have the condenser. The remaining set, whatever we are drawn in the earlier figure, no, it was connected. That's it. So now you have to connect. Here you have to connect the condenser. So you have to have the reservoir over here. So this is known as fractional distillation. So this can be applied only for the small difference in the boiling point. Okay, so what happens when you are heating the solution, it goes like this. So when you are keeping the distance, whichever having the lower boiling point will come out first. But what happens, it will go step by step, then effective. For example, when you are keeping here, you have 50% of A plus 50% of E. When it comes over here, then you are going here. So what happens, 60A and then 40B. then here 70A, 30B, then here 80A, 20B. When goes to here, you will get the 100% A. So that 100% A will come out. So remaining that will be the solution itself. Then it is called fractional distillation. So just you are introducing a fractional column. That's all. Remaining all are same for the distillation. Whatever you are seeing that is simple distillation, that you can see it. Okay. So what are the mixture you can separate? No, the separation of acetone and benzene from their mixture you can separate in the fractional. So we have to put. So we'll keep that simple distillation. So when the simple distillation, if the difference is 10 to 12 Kelvin, that you can be separated. So what are the things you can separate? Benzene plus toluene. And then chlorobenzene plus bromobenzene. First one. And the second one, fractional distillation. If the difference is 5 to 10 Kelvin, that you can separate it in the. So what are the things? Benzene plus acetone, acetone plus methanol, so by using this method we can collect it. And then whatever we are going to see, vacuum distillation. And the third one is so in the vacuum distillation, suppose some of the compounds are when you are heating it will char. What we can do? You have to separate. Are able to understand what I'm saying? You are taking the compound, no liquids. Some of the liquids will be charred if you are heating. So, but you have to separate it. So what they are doing, they are reducing the flame, but they give the pressure. So when the pressure become equal to atmosphere pressure, the solution start boil, isn't it? So even if the boiling point is 70 degree, but if you are applying pressure, it will boil at room temperature itself. But what condition you are doing? What you are applying? Vacuum. So that vacuum can create a pressure on the solution. So it start boils. That is known as vacuum distillation. So that vacuum distillation, here you have the reservoir, no? So that reservoir you will connect through the pump, vacuum pump. You have to connect through the vacuum pump. When it connected through the vacuum pump, then it is called vacuum distillation. So otherwise we can say distillation under reduced pressure. So this can be applied when the solution reaching the boiling point. If it is decomposed, that we can use this. Okay. So what are the things? So third one is vacuum. So what are the material we can take? So whatever decompose, if it reach the boiling point, okay. So example glycerol. Glycerol you can separate in this method. And then next one is, so simpler அதுக்கு ஒரு diagram போட்டோம்னு வச்சுங்க. So kindly you have to bear with me. All of you can see your textbook. It was given very nicely, the diagram. Here it was connected with a pump. Then you have to heat it. Here you have that. Thermometer. Okay. So water inlet, water outlet. Why we are keeping water inlet over here? Why here water inlet? Why not here? Because when you are cooling here, the gas gets cooled there itself. Then it become a liquid. Then it come back to the reservoir, your RB flask. So it back to the RB flask. That's why you are cooling over here. When you have the chill water, so what happened? The chill water, when it gets cools, no, it will take the energy, heat energy. Then when it goes out, no, that became a hot solution. Okay, wow. So the water outlet become hot. Next, steam distillation. So when you have the water, hot water and steam have more boiling point than the hot water. So if the convenient method, it's not separated. So you have, if you are heating that material is not going for the boiling point, means when you are introducing the steam, you are passing the steam into your organic compound. Because of that, it start boiling. And then if you are separating, means that is known as steam distillation. So this method is convenient for the separation of organic compound from the non-volatile organic and inorganic impurities. Some of the organic non-volatile இருக்கும், அது வந்துட்டு we can separate. So first என்ன பண்ணணும்னு பாத்தீங்கன்னா, you should have the steam. You have to generate a steam. So இது ஃபுல்லா என்ன எடுத்துக்கணும்னா water. இது ஃபுல்லா என்ன எடுத்துக்கணும்? You should have the water. So when the water, if you are heating, it will generate a steam. So that steam you have to immerse into the conic RB flask. So இதையும் ஹீட் பண்ணணும், இதையும் ஹீட் பண்ணணும். ரெண்டே ஹீட் பண்ணிட்டு இதுல இருந்து வருது இல்லையா, that you have to collect, condense பண்ணணும். அதை வந்துட்டு condense பண்ணணும். So water inlet, water outlet. So if you are getting, you will get the purest compound. So this is known as, so finally you have the four. One is, what is that? Steam distillation. Using the steam, if you are distillation, it is called steam distillation. So if you have non-volatile impurity, organic and inorganic impurities. So example, essential oil, nitrobenzene and chlorobenzene, that you can separate into this distillation. So the principles of normal steam distillation is equal to, it's based on the Dalton principle. Steam distillation is based on the Dalton's law of partial principle. That is the total pressure of the liquid become atmospheric pressure become P1 plus P2. That is the vapor pressure of the water. One is the vapor pressure of water. Two is the vapor pressure of your organic liquid. That gives the total pressure of atmospheric pressure. Then the liquid start boiling. So when it goes and cooling means that organic compound goes that side, water coming inside. That's all. Okay. So this is the method by which you can separate it. What happened? So next, we are going for the extractions. Now, we are saying chlorophyll that is present in the plant. Okay. So we are saying some of the organic compound which is present in the plant. That compound we have to isolate. So in the early days, what they have done, they will then solvent extraction. That means you have to take that material and put it into the solvent containing beaker. You have to heat it. So heat whatever soluble component which is present in your plant, that will be extracted in the solvent. Now, if you are taking the solvent and evaporating the solvent, you will get the compound. This is called extraction. Okay, simplest extraction. So you are taking a plant leaf. So all the leaf you are grinding and put it into the RB flask, and then you are pouring the solvent. Then you are heating for some time, or keeping and stirring for some time. So what are the soluble component which will extracted in your solvent? So that is known as solvent extraction. Here, the solvent extraction, we have different types. For example, extraction of nicotine from the tea leaves. That is also possible. You have to take the tea leaves and put the solvent for some time. It will give that. Okay. Now, suppose if you are having mixture of solution, that you have to extract. So, organic compound that will be dissolved in the solvent. So, what are the methods by which you can organic compound you can separate it by using solvent extraction? So, we are taken solvent extraction. Okay, you are taking two immiscible liquid. Immiscible means what? Huh? It can't mix together, but by varying the density, the lower density will come to upper side and the higher density will come to the lower side. So if you are taken water on the organic solvent like chloroform or ethyl acetate and then dichloromethane, so it vary the density. For example, water having lower density than chloroform and dichloromethane. At the same time, it will become less than ethyl acetate or diethyl ether. So, most of the organic compounds are soluble in ethyl acetate, diethyl ether, chloroform, and dichloromethane. Based on that, you can extract it. So now we are doing the reaction. So look this. So I am taking toluene. I am doing oxidation. I am getting benzoic acid. Now the mixture is contained 90% of benzoic acid and 5% of toluene and other impurities. Okay, so okay, for the calculation you have the 10% also. That doesn't matter. Now you have to separate. How you can separate? Now another thing, it will become liquid. It will become solid. But in the reaction, it's neither solid nor a liquid. Some gel form. This you have to separate it. Liquid distillation பண்ண முடியாது because ஒன்னு solid இன்னொன்னு liquid. Crystallization பண்ண முடியாது இல்லையா? Fraction crystallization பண்ண முடியாது, எதுவும் பண்ண முடியாது. அப்ப என்ன பண்ணலாம்னா the best way compounds, organic compounds, we can separate acidic, neutral and basic. அப்படின்னு separate பண்ணுவோம். So what is acidic? So those who are acidic which will contain RCOOH, and then phenolic compound. If the compound which will contain RCOOH and phenols, they are soluble in, they are acidic. So once it is acidic means if you put the sodium hydroxide, it can react. Okay, because phenol is a weak acid and carboxylic acid is a, compared to phenol, it's a strong acid. Okay, and then it will dissolve in sodium bicarbonate, aqueous sodium bicarbonate or aqueous sodium carbonate. That means that salt will be dissolved in that. Okay, so in the mixture, toluene and benzoic acid mixture you are taken, that you put it in the ethyl acetate. Ethyl acetate won't react, but you are adding sodium bicarbonate and shaking. What will happen? One compound goes to the ethyl acetate, the other compounds will come to the aqueous layer. Which compound will come to the aqueous layer? I am taking sodium bicarbonate. Which compound comes to the aqueous layer? So tell me, ethyl acetate is a solvent. Okay, so now ethyl acetate is a solvent when you are mixing with water. So இப்படி ஒரு flask இருக்கும், இதுக்கு பேர் வந்துட்டு separating funnel னு பேரு. Okay, so you have the lid. அதை க்ளோஸ் பண்றதுக்கு ஸோ என்ன பண்றீங்க, எத்தில் எஸ்டேட் வாட்டர் ரெண்டும் போடுறீங்க. அப்ப என்ன ஆகுதுன்னு கேட்டீங்கன்னா எத்தில் எஸ்டேட் மேலையும் வாட்டர் கீழையும் இருக்கும். பிகாஸ் எத்தில் எஸ்டேட் இஸ் லெஸ் டென்சர் தென் வாட்டர். ஸோ இப்போ என்ன பண்றேன்னா இந்த ஹோல் திங் டொலுவின் பிளஸ் பென்சோயிக் ஆசிட் இது ரெண்டுத்தையும் மிக்ஸ் பண்ணிடணும். ஓகேவா? எதுல? எத்தில் அசிட்டேட்ல போடுறோம். ஸோ இப்போ எத்தில் அசிட்டேட் ஃபுல்லா என்ன இருக்கு, இது ரெண்டுமே டிசால்வ் ஆயிடும். ஆர்கானிக் காம்பவுண்ட் will dissolve in organic solvents. Now you are adding aqueous sodium bicarbonate. That means sodium carbonates are dissolved in water. You know that when you have the acid, it reacts with sodium bicarbonate. It gives RCOONA plus H2O plus CO2 gas. It will liberate. Like when you are taking Coca-Cola and shaking, what will get? Effervescence getting no carbon dioxide is evolved. No. Likewise, when you are having carboxylic acid, if you are adding sodium carbonate and then shaking, means it will liberate carbon dioxide at room temperature itself. So it gives RCOONA. Once it is a sodium salt, it will dissolve in water. That's why if you are doing salt analysis in your laboratory, you are taking sodium carbonate extract. No. So why you are doing the lab? No. So you are doing sodium carbonate. Why you are converting into sodium salt. So double decomposition reaction you are doing, you are converting sodium salt. That's why it is soluble in water. So we know that most of the Covalent compound will not dissolve in water. For example, phosphate, sulfide, அது மாதிரி இருக்க காம்பவுண்ட்ல வாட்டர்ல டிசால்வ் ஆகுது. So to make it sodium sulfide, now it's sodium salt, then it is dissolved in water. புரிஞ்சுதா? ஸோ அதனால போடுறோம். இப்போ சோடியம் பைகார்பனேட் போடும்போது என்ன ஆகும்? இதுல இருக்க பென்சோயிக் ஆசிட் மட்டும் இட் ரியாக்ட் வித் sodium bicarbonate, it will form sodium benzoate, that is C6H5COONe. Now that will come to the water layer. The remaining will go to the which layer? Ethyl acetate layer. So when you are shaken, so it will separate it. 2 layers you will get. So you are collecting layer 1 and layer 2. So layer 1 enna pannalam? Then if you are putting HCl, it will give C6H5COOH solid plus NaCl. That will be in the solution. So by filtering you will get it. So I told you enna agum? You are taken the ethyl acetate, you are evaporating the ethyl acetate, you will get the toluene. So this is called separation of solvent extraction. So இத என்னென்ன compound பண்ணலாம் அப்படின்னா, so the compound which are water soluble, compound which are aqueous, this is the order, aqueous sodium bicarbonate soluble, and then aqueous sodium hydroxide solubility, and then dilute HCl. So water soluble என்ன இருக்குன்னா maximum of carbohydrates and then aliphatic diamide. So இது என்ன இருக்குன்னா mono or dicarboxylic acid. aqueous sodium hydroxide la carboxylic acid along with phenols. Phenol, liquid phenol, solid phenol, everything is there. So look here. Here carboxylase, here also carboxylase. What is the difference between these two? Sodium bicarbonate is a weak base, sodium hydroxide is a strong base. Sodium bicarbonate is weak base, sodium hydroxide is strong base. You may ask, sir, phenol is acidic. Why it is not soluble in sodium bicarbonate? Phenol is weakly acidic, sodium bicarbonate is weakly acidic. So the H plus the sodium bicarbonate cannot replace the H plus ion. Whereas sodium hydroxide is a strong base, it will give Na plus and OH minus, so that can be replaced. Okay, and then dilute HCl, amines, and then the last one, neutrals. So neutral means you have nitro compound, ester, aldehyde, ketone, amide. All other functional group comes under. So the organic compound we are separating like this. You may ask, sir, starch is a carbohydrate, but it is not soluble. புரியுதா? Starch வந்து soluble ஆகாது. So அது வந்து solvent separation ல இருந்து different ஆகும். Is it clear? So these are the method by which you can purify that your compounds. And then chromatography. So chromatography is a beautiful technique. Chroma means color. So by using 2 principles, you can separate. One is adsorption chromatography, another one is partition chromatography. So what is adsorption, what is partition, that we have to learn. Tell me more. So the test what scientist test out only, he find out he is a botany scientist. He taken the chlorophyll and put it into some column. He closed the column and they poured some solvent. When he back to the next day, when he see that column, the color was separated. So the technique was first invented that place only. So when you are adding organic solvent, the organic compound will be separated in different colors. So by extracting, you can collect the different layers. That is known as chromatography. So how far it useful now for the organic compound purification? The better techniques. You can take the liquid sample or you can take the solid sample. So what you have to do? So based on the two principle, it can be separated. What is that? One is adsorption chromatography. Another one is partition chromatography. So what is the principle behind that adsorption and partition? So you have two phases. In the chromatography, you have two phases. One is fixed or stationary phase, and another one is mobile phase. So now what is the difference? If I'm saying stationary phase, or fixed phase, and then mobile phase, MP, not melting point, mobile phase. So you can see in the adsorption chromatography, in the solid phase is your, this is your solid. Stationary phase is a solid, and the mobile phase is your liquid. Whereas in the partition, the mobile phase, stationary phase, it may be solid or liquid. These things that will be supported in a adsorbed on solid support. And then mobile phase is a liquid. So the distribution of compound between solid and liquid able to give this chromatography. Okay. First, what if you have the column like this? You may have the stopper also. It's a glass tube. Okay. In this glass tube, you can use the adsorbent and then solvent. Adsorbent generally alumina, magnesium oxide, silica gel. இப்போ நம்ம புதுசா ஒரு திங்ஸ்லாம் வாங்கணும், ஒரு குட்டி பாக்கெட்ல வருது இல்லையா, அதுதான் சிலிக்கா ஜெல். அதோட மெஷ் சைஸ் பெருசு, மெஷ் சைஸ் சின்னதா குட்டி. நம்ம வந்து யூ கேன் டேக் த சாண்ட் அண்ட் மிக்சிங் தட் கால்சியம் கோலமாவு இருக்கு இல்லையா, அந்த மாதிரி இருந்ததுன்னா அதுதான் சிலிக்கா ஜெல் பவுடர். இப்போ என்ன ஆகுதுன்னா, when you are mixing your organic compound with that, it will adsorb. The organic compound will be adsorbed on the silica gel. So இந்த மாதிரி காலம் எடுத்துட்டு you have to put the cotton over here. So whatever blue color is there now, you can put the cotton over here, and then you have to fill up to this as a adsorbent at particular height. Okay, and then you have to take your compound. Okay, compound that you have to adsorb on the silica gel. So you have to have a compound over here. So we are having compound. So here the compound, another adsorbent. So here you have the cotton. Now you are adding a solvent. So what is the role of solvent? It will elute the compound. It will elute the compound. So that compound will travel through the silica gel. So it has a length, it will take slowly, it will travel. So whatever having non-polar compound, it will come out first. The polar compound will come out later. So now what is polar and what is non-polar you should know. Then only you can do this chromatography. So when there is electronegativity difference between two atoms means that will be polar. For example, you have taken alcohol. Alcohol is more polar because the carbon and oxygen. Oxygen is more electronegative than carbon. That's why polar. If you are taking hydrocarbon, carbon, hydrogen, there is not much difference. So it will become a non-polar. So same way, if you have to choose a mobile phase, you should not use directly polar solvent. You have to use first non-polar solvent and then slowly you have to increase the polarity. So what if you're taking hexane, it's a non-polar solvent. Ethyl acetate, it's a polar. Or methanol is a polar. So what we have to do? 1% of methanolic solution of hexane, 2% of methanolic solution of hexane. Slowly you have to add. So when you are adding compound plus impurity will be there. The compound slowly travel. Whatever, if it is 2 or 3 compound also will be there. The compound 1 plus 2 plus 3. So first என்ன போகும் ஏதோட polarity இருக்கோ இங்க வந்து A B C மூணுமே இருக்கும். அடுத்து வரும்போது என்ன ஆகும் A is more than B and C. Then A is more B C இங்க இருக்கும். Then A is more B and C இங்க இருக்கும். So at last ஒரு band same polarity யூஸ் பண்ணும்போது இது எப்படி சார் மெஷர் பண்றது அப்படின்னா இதுக்கு முன்னாடி you should know the thin layer chromatography TLC. When the small plate, okay, small glass plate which is coated a silica gel or aluminum, you can coat the aluminum. The aluminum plate or glass plate which is coated with silica gel, இப்போ என்ன ஆகும்னு கேட்டீங்கன்னா it will become like a tablet மாதிரி மேல வந்து கோட் ஆயிரும். Now you have to have some distance, you put the line and then you can spot and then if you are keeping this into that solution, so you are preparing 10% solution, 20% solution like that. Now this plate you are immersing, through the capillary action solvent will flow from here to here. Okay, நம்மளே கண்ணிலே பார்க்கலாம் ஸ்லோவா. capillary action என்ன அர்த்தம்? capillary உள்ள போட்டதும் water அந்த capillary layer இல்லையா, that is known as capillary action. Same way when you are keeping the paper and immersing to the solution, so what will happen? That solvent will flow from bottom to upper level, so through the capillary action. So when the solvent comes, if the solvent dissolve, whichever having less solubility, it goes first. Okay, so when it goes after immersing the solvent, so the first one you are putting the second, then third, so you are keeping spot over here, so it will come like this, it will come like this, it will come like this, it will come like this. So up to this distance solvents is traveled. Okay, so you may have the spot like this, you may have the spot like this. So it tells what, so look the spot and all. So 1 2 3 4 5 spot. So the first spot at it goes up to this level, whereas solvent run this level. So you have to measure what is the distance between these two and these two. You can find out retention factor. So the distance traveled solute or solute from the baseline. So this is the one. Okay, so distance traveled by 1 divided by distance traveled by solvent. It is solvent. It gives the retention factors. Okay, so இப்போ வந்துட்டு இது வந்து 1 ன்னு வச்சுட்டோம், இது 2 ன்னு வச்சுக்கிறோம், இது 3 ன்னு வச்சுக்கிறோம், இது 4 ன்னு வச்சுக்கிறோம், இத வந்து x ன்னு வச்சுக்கிறோம். So the 1 by x will give the RF factor of 1. 2 by x will give the RF factor of 2. 3 give the 3 by. So now this RF value, what it tells? For example, 1 will go 1 centimeter. 1 will go 1 centimeter, that divided by, then solvent is goes 5 centimeter, and the 2 it's going 3 centimeter by 5 centimeter. 3 is going 2.5 centimeter by 5, and 4 is going 1 by 5. So 1 by 5 means what you will get? 0.2. 3 by 5, 0.6. 2.5 by 5. Then for this, 0.2. Okay. So whatever distance more, no, when you are getting RF value is more, then it is non-polar. Whichever you are getting RF value more, that become non-polar. RF value is less, it become. So based on the RF value also you can compare the polarity. So that means what? Whatever the compound which is less adsorbed on the solvent, adsorbed on the bed, it flow go fastly. Whatever the solute which is adsorbed strongly, it go less. அதாவது சிலிக்கா ஜெல் எடுத்துக்கிறீங்க இல்லையா, அதில் காம்பவுண்ட் ஏபி போடும்போது எது லூஸ்லி பவுண்டடா இருக்கோ இட் வில் கம் ஃபர்ஸ்ட். அதுதான் நான் போலார் சொல்லுவேன். ஏன்னா சிலிக்கா ஜெல் இஸ் OH, இட் ஹேஸ் a strong polar. சிலிக்கா ஜெல் இஸ் polar. அப்போ போலார் காம்பவுண்ட் will have strong bind with the polar. அதனால என்ன ஆகும்? ஸ்ட்ராங்கா அப்சர்வ் ஆயிருக்கிறது போலரா இருக்கும், less அப்சர்வ் ஆயிருக்கிறது நான் போலாரா இருக்கும். When you are adding non-polar solvent, the less solubility will come. When you are increasing the polarity of the solvent, the polar compound will break down the physical bond between. It's not chemical bond. Physical, through the force of attraction it was attracted. It will come out later. இதுதான் TLC. இப்போ ஒரு ரியாக்ஷன் நடந்திருக்குன்னு வச்சுக்கோங்களேன், the starting material here பேஸ்ட் பண்ணிருக்கீங்க, கொஞ்ச நேரம் பொறுத்துட்டு ரியாக்ஷன் போனதும் அந்த ப்ராடக்ட்டை இங்கே பேஸ்ட் பண்ணிருக்கீங்க. இதை TLCல வச்சு பார்க்கும்போது what is the difference between, இதை எடுத்து UV லைட்ல வைக்கிறோம்னு வச்சுக்கோங்களேன், அந்த கலர் தெரியும், ப்ளூ கலர், எல்லோ கலர், அந்த மாதிரி கலர்ஸ் தெரியும். அந்த UV லைட்ல வச்சுட்டு வாட் இஸ் த டிஸ்டன்ஸ் இட் மூவ், அதை வச்சு நம்ம புரிஞ்சுதான்? இல்ல அயோடின் சாம்பர்ல போட்டா அதுவும் தெரியும். சார் கிட்ட சொல்றோம், அந்த TLC மட்டும் இங்க ரெடி பண்ணி காமிக்கணும். ஓகேவா? ஸோ இதுதான் வந்துட்டு தின் லேயர் குரோமடோகிராஃபி. இதை பேஸ் பண்ணி தான் காலம் குரோமடோகிராஃபி. இதுல எப்படி ஸ்லோவா வருதோ, இப்ப மேல எந்த ஸ்பாட் ஃபர்ஸ்ட் வந்தது அந்த ஸ்பாட் தான் காலத்துல இருந்து முதல்ல வெளியே. இப்ப நீங்க சால்வெண்ட் கீழே இருந்து மேலே ஏத்துறீங்களா, அதுல என்ன பண்ணுங்க, சால்வெண்ட் மேல ஊத்துறீங்க, அந்த அப்சார்ப் ஆனதுல இருந்து கீழே இறங்குறது, அவ்வளவுதான். This is called adsorption and partition chromatography. Partition chromatography என்னன்னா, உங்க காம்பவுண்டை வேற ஒண்ணு டிசால்வ் பண்ணி ஒரு பேப்பர்ல வச்சிடணும், அந்த பேப்பர்ல ஸ்ப்ரெட் பண்ணிடணும், அதை ஒரு சால்வெண்ட்ல டிப் பண்ணணும், கேபிலரி ஆக்ஷன்ல அங்க போகும். அதுக்கப்புறம் அதுக்கான தேவையான ஸ்ப்ரேயிங் ஏஜென்ட் போட்டு you can find out what is it called partition. Okay, so that's all about the chromatography. Okay, whatever doubts you are getting, you study and then come.